Title: Saving Yosemite's Frogs. Next to a still, shallow pond, researchers set up netting in the water and take notes on shore.
The Sierra Nevada yellow-legged frog was once the most abundant amphibian in the Sierra Nevada and probably the most abundant vertebrate.
A 3-inch long brown frog.
Back into the early 1900s, we had researchers in the park and also just park visitors, and we have reports of them going all these different lakes, and they'd see hundreds or thousands of these frogs.
A frog rests on a sunny rock.
And they talk about how when they were walking along, they had to watch where they were stepping because there were just so many frogs.
A frog sits on a rock in a river.
So Yosemite is known for this incredible landscape, this incredible glacially carved landscape. And as a result of this landscape, we wound up with over 2,500 lakes in Yosemite. And one of the interesting things about these lakes is that they evolved without fish, because we have these grand cascading waterfalls that prevented the fish from being able to populate those lakes after the last glacial period.
A waterfall plummets thousands of feet.
And so you have these great ecosystems that evolved with animals like the Sierra Nevada yellow-legged frogs and this incredible invertebrate diversity.
A tadpole swims.
And then starting in the late 1800s, we started fish stocking. We started stocking lakes with things like rainbow trout and brook trout and brown trout that people loved to fish. And what happened is the fish started competing with the frogs and preying on the frogs, and we started losing frog populations very rapidly.
By the 1960s and 1970s, we were seeing the end game in that process, which was the virtual elimination of mountain yellow-legged frogs from most of their former habitat by fish introductions. That's a dramatic change, and that dramatic change has meant that not only is the amphibian disappearing, but all the pieces of the ecosystem that depend on that amphibian or are affected by that amphibian are also being changed. So we have garter snakes that were once a major predator on mountain yellow-legged frogs, now disappearing as their prey. The mountain yellow-legged frog disappears.
Fish jump in these still river waters.
One of the reasons that frogs and fish can't coexist is because, for one, the fish feed and prey on the frogs, but they also compete with them for food. They compete with them for the same kind of invertebrates.
By the 1990s, we started to notice really steep declines. And so we were trying to figure out why this was happening.
It became clear to me that something else was driving declines of this frog, in addition to fish.
They would find hundreds and hundreds of dead frogs in the lakes, and people started asking what was going on. Was it something in the environment? Was it pesticides? Was it UV radiation? What was going on? And it wasn't until 1999 that we finally identified the amphibian chytrid fungus as the primary factor that was causing these massive declines.
Frog corpses lie belly up on the river bottom.
So the amphibian chytrid fungus is a non-native species that we think evolved with the African clawed frog in sub-Saharan Africa. And starting in the 1930s, this frog that evolved with this pathogen started being transported globally throughout the world for laboratory experiments and pregnancy tests and the pet trade. And you can track the shipping of this frog with the spread of this disease that's now blamed for the extinction of probably 200 species of amphibians throughout the world.
Researchers collect frogs on a riverbank.
What this amphibian chytrid fungus does is it grows inside the frog's skin, and if there's enough of that fungus growing in the frog's skin, it'll eventually kill the frog. But basically, the frogs can keep the infection low, the amount of chytrid that's growing in their skin low enough that they're actually able to survive even though they're infected. And so in Yosemite today, we assume that every single living population in the park is infected with this amphibian chytrid fungus.
High in the isolated mountain wilderness, a park ranger walks next to a small lake.
At this stage, we really can't control chytrid, but what we can do is we can increase the amount of high-quality habitat that we have for the remaining populations of Sierra Nevada yellow-legged frogs in Yosemite. What we've done in Yosemite is we've identified the most advantageous places in the park to do restoration, to recover the frog. And by restoration, I mean eradicating the non-native fish.
Researchers spread a fish net.
So the goal of the project is not to remove fish from the entire park or to remove fishing. We realize that's a recreational activity that people have been doing for decades, and it's really important to some people. So we're not trying to get rid of that. The goal is to restore habitat for the frogs by removing these non-native predators at some select sites.
A ranger studies a small fish in a net.
So what's exciting is we're actually seeing these chytrid-positive frogs moving back in and recolonizing sites where we're doing habitat restoration. So we're seeing success from our fish eradication efforts.
A clump of swimming tadpoles.
So what we've seen over and over is after we've done these fish removals and the frogs have recovered, we've watched all those functions that are related to the frog also recover. So we've seen the recovery of these invertebrate populations, which are now food for this increasingly abundant frog. And we've even seen effects of that recovering invertebrate population on terrestrial predators like birds. So rosy finches are a really common bird in the alpine zone where there isn't a whole lot of food. And what we've seen is as the food resource from these lakes increases following fish removal, the rosy finches begin to target that food resource. And so they are very dependent on resources that are coming out of those lakes.
So we know even in the face of chytrid, we know that if we restore these habitats, these key habitats for the frogs, that we are going to have success and that we are going to be able to increase the number of healthy, viable populations in Yosemite and hopefully keep the species from going extinct.
A frog clings to a rock wall in the shade.
I would love to see a day where we have basins in the Sierra Nevada that are teeming with frogs once again.
A close-up of a frog resting on a rock with its rear legs in the water. Other speakers in this video were introduced via on-screen text as Travis Espinoza, wildlife biologist, Heather McKinney, aquatic ecologist, Roland Knapp, PhD, aquatic ecologist, University of California.